The vaporized silica aerosol hypothesis suggests the luminous filaments are composed of nanoparticles. It floats. It hisses. It doesn't behave like a spark.
By precisely controlling the high-voltage discharge, we generate a stable plasma formation, allowing us to...
As hypothesized by the vaporized silica aeros theory, the high-voltage discharge at this pressure allows...
While often dismissed as myth, controlled experimentation suggests the phenomenon is a real, short-lived aerosol.
Replicating conditions where vaporized silica aerosols can induce plasmoid formation.
By applying the high-voltage silica, we hypothesize the formation of a stable plasmoid structure.
We are observing the silica aerosol plasma formation. Note the high luminosity and short duration of the event.
Colors vary: whites, blues, oranges.
The vaporized silica aerosol theory suggests that ball lightning is a mesh of silicon filaments. As the plasmoid forms,
Following the precise high-voltage discharge, the synthesized silica plasmoid stabilizes. The overlaid data tracks the subsequent energy decay phase.
Under controlled conditions, high-energy plasma discharge can replicate the atmospheric conditions required for a
The vaporized silica aerosol theory suggests this reaction is a brief, highly energetic oxide breakdown.
Witnesses mention rotating skins, inner cores. Some end silently, simply fading away.
As predicted, the silicide aerosol became unstable, leading to a rapid contraction and subsequent energy relief.
Simulations allow us to isolate the crucial material evidence.
While myth requires us to believe in an arbitrary force, science demands a testable hypothesis.
Modeling the conditions required for the silica aerosol hypothesis.
This controlled discharge demonstrates how a naturally occurring energy burst can create a luminous, long-lived orb. Our job is to test, not assume.
As the field intensifies, the energy density within the confinement area rapidly increases, as you can see in the data. The vaporized silica aerosol theory suggests that under specific high-energy conditions, a true plasmoid can be generated.
This controlled discharge demonstrates the core plasmoid structure.
As hypothesized by the silica aerosol theory, the high-voltage discharge across the particulate creates a pheromones.
The high-voltage discharge instantaneously converts the target into a vaporized silica aerosol. As you can see, the
Magnetic fields could confine a hot core briefly. Microwaves can create glowing plasma from carbon or salt traces.
When the electromagnetic pulse hits the cavity, it generates standing waves, visible here as kinetic golden lines. A window gap can act like a waveguide for RF energy.
At 13.56 megahertz, the RF field stabilizes the plasma. This allows for temperatures exceeding 10.
Another idea. Lightning vaporizes soil. Silica turns to aerosol. Burning silicon nanoparticles can glow while diffusing. Chemistry plus airflow equals drifting luminous spheres. Walls and wires can shape the path via fields.
As the sphere dissipates, we observe the temperature differential reaching 5,000.
While observational evidence is compelling, evaluating the physical stability and real energy budgets remains the critical scientific bottleneck.
Combustion of carbon/silica can sustain light briefly. scaling law demonstrates that maintaining a stable plasmoid requires an exponential increase in energy relative.
The high-voltage discharge creates immediate ionization, resulting in the visible plasmoid. Note
The measured drift correlates precisely with the visible formation of the von Karman vortex stream, demonstrating the effects of. While modern devices can mimic the appearance, scientific rigor demands control, allowing us to isolate the precise spectra,
Separate hot plasmas from LEDs.
As the voltage peaks, the plasmoid begins its inevitable decay. Note the 1.2 millisecond decay rate as it loses coherence.
This vaporized silica aerosol model offers one mechanism, but remains difficult to replicate consistently.
We are now observing the formation of the synthetic plasmoid. The kinetic data highlights the extreme condition.
We are now observing silica-induced selective regeneration.
Flares stick to lens symmetry, not the scene's geometry. This controlled event demonstrates the formation of a vaporized silica aerosol, a leading candidate for true ball lightning. This is the plasma aerosol model at 1,000 frames per second, isolating the silicon vapor's luminescence.
Two angles kill many fakes instantly.
What we're looking for is a genuine plasmoid, a controlled glimpse into the mechanics of vaporized silica aerosols.
As the high-voltage discharge ignites the SiO2 target, the resulting plasma sphere exhibits its property. The correlation between the energy discharged and observed phenomena is evident. The strike density directly impacts the voltage potential across the grid. As the high voltage arcs, the silicon dioxide undergoes controlled ablation. The resulting plasmoid is stable.
Sample residues, soot, silica, metal traces, all critical indicators of high-temperature ablation. Here, the vaporized and silica aerosol theory is put to the test.
The silicon aerosol theory posits that under these specific dielectric barrier discharge conditions, vaporized,
As predicted by the silica aerosol theory, the controlled high-voltage discharge creates a stable plasma formation within the vacuum chamber.
We are analyzing the vaporized silica model. The high-speed camera captures the brief, luminous sphere and the
As the charge stabilizes, we observe the plasmoid's current density. Note the rapid decay rate, consistent with the vaporized silica aerosol theory.
We are witnessing the rapid ionization process. The arc stabilizes immediately, forming a contained
Under these controlled conditions, we initiate the plasma. This localized energy spike creates what we identify as a simulated silicon plasmoid.
This lab reconstruction, captured from multiple synchronized high-speed cameras, isolates the energy signature characteristic of the plasmoid hypothesis.
the controlled discharge initiates the psi vaporization, allowing the silicon aerosol plasmoid to form momentarily in the chamber.
Log time, wind, lightning alerts, and direction.
According to the silica vapor hypothesis, the plasma sphere is sustained by a matrix of silicon-oxidized nanoparticles.
Inoxidation mechanism is critical to stabilizing the plasma, allowing for sustained oscillation and multifactorial thermalization.
Photograph residues before rain erases them. This controlled event validates the vaporized silica aerosol model.
The core principle of the vaporized silica aerosol theory relies on the stability of the plasmoid, as demonstrated by this discharge event.
Unknowns remain. What powers the longest events?
The critical factor is the probability of plasma initiation inside residential structures, which correlates directly with the RF burst.
By replicating the atmospheric conditions, we isolate the fundamental mechanics of the silica aerosol plasmoid. As we introduce the high voltage, Observe the immediate formation of the plasmoid. This controlled event allows us to
crystals. The sharp electrical discharge causes immediate ionization within the chamber. We are specifically analyzing the resulting aerosol.
If you value clear, careful science, subscribe.
The phenomenon is brief, but the evidence is absolute. The stabilization mechanism relies heavily on the containment field. Once breached, the resulting aerosol accelerates the decay process.